recording started.
Okay, good morning everyone. So let me talk about Chapter 4, and this is going to be our second session. So we already talked about a few basic concepts in this chapter, and especially we talked about the Boolean operators and the logical expressions. So you had to make sure that you go through every single one of these exercises, and if you can, right, the main idea would be that you also run these. Let me see if I can get into my Visual Studio, right? So you should have a project, and if you want to, you can start a brand new one, or add a new source file, or you can add an existing file. And let's see if we have under Chapter 4 data files, Chapter 4. Let's pick one. So it doesn't really matter which project we're gonna, or what file we're gonna be picking from. Okay, but that could be a basic structure. This can be a basic structure that you're gonna be working with, right? So you can get rid of some of the code and then start working with this particular file. Okay. Or what you can do is just to remove this, start a new item, just for learning purposes. So let me add that too. So just have some kind of a source file that you can basically just play with. Okay. So let's see what is it that we need to talk about in this particular example. So let me go back to the slide. Okay. So here we have to working about, or maybe I want to see how that works. I don't understand how that works. So 14 greater than or equal to 5, and A is less than B. Okay, so then you say cout, and I'm gonna type in 14 less than or equal to 5, and A is less than B. Okay, so maybe this is the one that I like to figure out how that works, or what's going to be the result of this. So what is this? Cannot determine. I'm not sure why to say it. Let's see if that's gonna be okay this way. Okay, and then maybe we can also include the same thing. Just to show that this is the result that I'm trying to display on the screen, right? And then we can put in the breakpoint. We run this application. Okay. and you can see this result is false. So you can run all the examples, even though you don't have an actual application source code given to you by the book author. You can just write in and just display the results, and then talk about why is this false, right? You can see that the value that this expression right here resulted is a 0. 0 is false. So A is less than B, but 14 is greater than 5. So what if I change this? Okay, or better yet, copy this whole line and then rerun the application again. Oops, let's make this change greater than or equal to. So we can also see the changes in the output. Okay, so now you can see that the first one is 0 and the second one is 1. Okay, so you can do these kind of things with your compiler. So using the breakpoint is always going to be your best friend, especially when you are talking about expressions that go through multiple stages, and you might want to break the expression into parts or portions. And let's say over here, maybe I'm going to have a Boolean value A, B, C, and D. And what I like to do is A gonna be equal to whatever this expression is, and then B gonna be equal to whatever this expression is. So C is going to be this expression, and then D gonna be this expression right here. Okay, and then I want to say A and B, and here C and D. Okay, so make sure that you stop the code and then relaunch it. You can see that the expression is still correct, or the results are still the same. Now, why would you do something like this? Well, I would recommend you doing it this way, because in this fashion, because we have the actual variables and the variables set to particular values, you can see as we are stopping the code from running, so we have a breakpoint set. With the breakpoint, we are in debug mode, and in debugger we can see that A is false and B is true, and that's why A and B is false. Now when you look at C and D, C is true and D is true, and that is the reason why C and D is true. Okay, so if you break up the expression into variables, store the values in a variable, then you can actually look at each individual step in the evaluation, and you can learn a lot better the Boolean expressions. Okay, so use your Visual Studio or whatever compiler you have, whatever IDE you have, to learn about the statements, whatever is covered in that particular chapter. So it's a really good way of looking at statements that you might not have an actual sample code for within a particular chapter. Okay. So that's how you would actually evaluate the logical expressions using Boolean operators. Okay, so we also talked about the associativity and the order of precedence. So we have an order of precedence for operators, also for comparison operators or Boolean operators. So arithmetic's gonna be evaluated before any kind of a comparison, and then the Boolean expression is gonna be evaluated. Okay. So here you have some example code that you can play with, and that means we can actually load up that code. So here we can remove the source code and then add an existing item, and we are in chapter 4, and maybe we want to look at the associativity of relational operators. Okay. So this is a concept what the chapter is talking about, but this is not really what I would like to talk about right now. So let's add another one. Okay. So let's look at the logical operators. Okay. And so now you can see that this is exactly the code what the book author is talking about in the chapter. And then you need to see if you understand what he's talking about. Why are we talking about modifiers for the CR statement? So now you should have a good understanding what that means. Okay. And then look at all these different expressions. Okay. And then you can modify them and change some of the comparisons, change some of the values. But again, you want to break the code, launch it, look at the output, and based on the output, see if you understand every single one of these lines and what they represent. So found with a exclamation point in front of it evaluates to 0. Okay. If you put your cursor right over that variable, then you can also see it in real time that the value of that is false. So not false. Okay. So found is true. Now not found is false. But you only do that for display. So really you did not change the value of the variable. How do you know that you did not change the value of the variable? Is because found is still true. Because that's the only assignment we have. This is just for display purposes. We are flipping the Boolean value when we display it. We did not change the actual variable value. Okay. So you go to the next line and say, okay, why is hours greater than greater than 40? Well, hours is 45.3. You can see that even though you assigned, remember this is double. Remember what we talked about last time, that a double or any kind of a floating point value is a rounded value. So now you can see that 45.3 is really stored as 45.299999997. So it's not really 45.3. So you cannot really compare double values in an if statement. So that's what we talked about last time, that what you need to do is subtract whatever value you're comparing it, compare this double value to, and look at the tolerance. And we also said that we don't want to find out which one is larger and which one is smaller, so sometime we get a negative value. If we get a negative value, we have to look at the absolute value of the two values subtracted before we compare it to the tolerance. So anyway, the actual debugger can teach you a lot more about how computers work and how computers store values. So ours is 45.3. 45.3 is greater than 40. So what it returns is 1. 1 is true. And really, when you look at this, okay, ours greater than 40 is actually returning or evaluates the true. You can see it in real time right here. Okay. But that did not change the value of ours. This is just comparison. This is not an assignment, right? So we have age. What is age? Age is 20. Age is 20. Okay. And when we are evaluating age and we're negating age, now negating age is 0. Now why is that? Well, really, when you're thinking about Boolean operators, a Boolean value is anything but 0. And if it is 0, then that means false. So is there any way that we could actually test that whole concept? Well, let's just add some values in here. Okay, so I'm going to stop this code right here, and let's look at an if statement. Right, so if statement starts with a block. This is your true block, right? So I want to put in. I want to put in a comment to show that this is my end of the true block, and I can put in the else statement and then put that also into a block, and that's going to be end of false block. And what happens if I type in true? If the if statement evaluates the true. So I can print out I'm in the true block. Okay, and if the expression, okay, so this is the expression that's going to be evaluated, and here I'm in the false block. Okay, and I'd like to see how that works. So I put the breakpoint right before the application would exit. So I want the code to stop right here and run the code. And you can see that I'm in the true block. So what does that mean? True, expression evaluated to true, will only execute whatever is in the true block, and the else block is skipped. Okay, so let's stop it and then see what if this is going to be false. Okay, so what if that's going to be false? Again, I run the application, and you can see that I'm in the false block. So now the true block, this block was actually skipped, and the else block was executed. So this is with Boolean value. So what if I type in, instead of false, I type in 0? So you can have an expression that evaluates to 0, or what we were talking about, false really means 0. Well, can we prove that? Well, here's the code, and we can just run it and see if we actually prove it. And you can see that I'm in the false block. So we are in the false block of this structure, this selection structure. Okay. So what happens if I type in 1? Well, 1 should be true, so it should only give me the statement which tells me that I'm in the true block. And you can see that, yes, that's what actually happened. So that's easy with the 0 and 1. But what if this gonna be evaluating to, let's say, 500? What's gonna happen then? You run the code, and you can see that I'm in the true block. So 500 also evaluates the true. Why is that? Well, let's look at another value. What if the if statement is minus, let's say, 48? Right, what's going to happen then? I'm in the true block. So you can test it, and you can play with this over and over again, and you're going to see that only the 0 means false. Any other number, any other integer that you're going to be typing in here, any other value going to be true. So it's not really true that only 1 is true, but anything else but 0 result true. And that's why you see that age negated is 0, even though age is 20. Anything else that is not 0 is true. So you're really negating 20, negating true to false. Okay. Again, you can see that if you have the compiler and then you play these little games, you play this little exercise to understand how these operators actually function, actually work. Okay, so we can get rid of this now. We don't need it, and let's go ahead and remove. And let's add another item, existing item, and let's look at this associativity of operators. That's a very interesting, very crucial exercise. Okay. So here we are displaying a message, and we're asking the user to type something in. And you might have an expression that shows something like that, and you say, okay, how is this going to be evaluated? So you run this code. Okay. You actually run the code, and it seems like what you're trying to do is a value that is between 0 and 10. So let's say if we add a value that's between 0 and 10. I put in 6. Oops, I need to break the code, otherwise it's going to close down when we type in the value. So let's type in 6. Number is 6. And 6 is within 0 and 10. So you would say, hey, my program works perfectly fine. Okay, let's run another instance of this, and let's say an integer is -4. Okay, it says -4 is within 0 and 10. No, that's not right. Okay, so you write the code, you design it, all right. You have a Boolean expression designed, and everything looks fine. The compiler doesn't see anything wrong with it. And the only way that you can find out that something is wrong is by testing with different values. And the different values would be the boundary values, outside the boundary, and also inside the boundary. So this is outside the supposedly boundary. Okay, so -4 is outside 0 and 10. The range of 0 and 10. So if we tested something in between the range, last time was 6, it worked fine. Now we are outside the range, and it still says we are within. So let's look at the other outside of range, the other side. So let's type in maybe 134 this time. Okay. And it says 134 is within 0 and 10. So where did we make a mistake? Why is this logical expression not working? Now if you look at this, okay, this is two different logical expressions. And how are we evaluating it? We're evaluating it from left to right. Okay, so if left to right evaluated, this is a binary expression. So you need to have the operator, and then you have two operands at the end. and on two sides of it. So what is the result of this operation right here? Let's say if we have something like what if we have the number that we typed in? Okay, number that we typed in was 6. Okay, then what's going to happen is 0 greater than equal to 6. Okay, now what is the result of that? Okay, or in this case 0 is less than or equal to 6, so that is true. Okay, what is true? True is 1. So then what is it that we're comparing? Now we are comparing the next binary operator, which is the less than or equal to, and we're comparing it to, you think you're comparing it to number, but what is it that you're truly comparing it to? Less than or equal to 10. What is it that you're comparing? The result of the previous operation. So what you're doing is 1 is 1 less than or equal to 10. What's the result? True. Okay, so what happens when we typed in the number is -4? What was the result? Is 0 less than -4? No, it's false. But what does false really mean? False means 0. Okay, so at that point, what is it that we're comparing? We're comparing 0 to 10. So is 0 less than or equal to 10? Yes, it is true. And then we typed in, let's say, 100 plus 134, right? So that is outside a range. So we had a range, and then we have the outside the range, where the range is 0 to 10. So we tried 6, we tried -4, and then we're trying 134. Okay, and then you look at it and say, okay, what is 0 less than or equal to 134? What's the result of that? Yes, 0 is less than or equal to 134, but true means 1. And at that point, you're comparing 1 to 10, and 1 is less than or equal to 10, so it's always true. So within the range and outside the range, we tested that we're never gonna get a false result for this expression. So how do we fix this? Okay, and that's when you're going to say that the number has to be greater than or equal to 0, and the number has to be less than or equal to 10. So now what happens? Now what happens is when we type in for the number, we type in 6. We compare 0 greater than equal to 6, and that's going to be true. Okay, so 0 is less than or equal to 6, that's true. And then what we do, we're comparing not the result of the previous operation, but the actual value that is stored in the number. So now we are saying 6 is less than or equal to 10, and that is going to be true. And now when we are combining the two with the ampersand, okay, now we are comparing true to true, and that's going to be true, right? Because the end operation is 0 and 0 is 0, 0 and 1 is 0, 1 and 0 is 0, and 1 and 1 is 1. And that's what we have here, true and true. Now let's see what happens if we have -4. -4 is negative or 0 less than or equal to -4. no, this is false. Okay. So at that point we are comparing -4, is it less than or equal to 10? True. But now what we're comparing is true and false, and then we have true and false. That's going to be false. So -4 is not within the range of 0 and 10. So when we type in 134, 134 is compared to 0. Okay, 134 is true, that it is greater than or equal to 0. But when we comparing the 134 less than or equal to 10, that's going to be false. So now the result also going to be false. And now this is the proper Boolean expression. Okay, so it's going to be very important when you're looking at Boolean expressions that you design the expression properly and you learn about these little problems that might arise as you are working with Boolean expressions. Okay, but again, so you did have the Visual Studio, your IDE, and with the IDE you can test these concepts, and you can put in breakpoints in the IDE and look at the debugger and figure out if you are on the right track or if you are understanding these concepts. Okay. So type in all these values and just print them out on a screen if it doesn't make sense on a paper or with the explanation what the author is talking about. Okay, you guys can play those kind of simple exercises. So string type, again, a string is a group of characters. So when we are comparing strings, we compare them, the placement value of each individual string, and we comparing the ASCII value, then the numeric value that represents a particular character. Now if we have a shorter word that is compared to a longer word, and the shorter word is a subset or substring in the longer word, then the shorter word is less than the longer word. Again, these are really nice examples that explain how that actually works and how these expressions are evaluated. Okay. So in order for us to understand how code actually works, it's really important for us to utilize the capability of our IDE, the programming environment. Okay, so is working properly. Okay. So a switch structure is going to be an important structure for us to know. Okay. So this is the flow chart. There's no really special flow chart for the switch structure. It's kind of like look like if statements. So that's perfectly fine. Okay. So make sure that you use the break statement when you're done. So the keywords that you need to know for switch is switch, case, break, and default. Okay. So this would be one of those examples again that you have the source code for. You want to make sure that you do run the source code. Okay. So make sure that you avoid bugs. So test your code. Don't just say that. Don't just think that you compile. There is not a syntax error, so you're gonna be fine, because you can still have logical errors in your code. Okay. So when you're talking about the assert function, just make sure that you understand the assert function. That if you have a code, okay, so if you would have a code and the code says something like, I don't know, int x and cin x, and then we're gonna have cout 5 divided by x. Okay. Now, what is dangerous about this? Why is this dangerous? Now, this is dangerous because we cannot test what the user is going to type in, and we know that if the user types in 0, the 5 divided by 0 is undefined. So, in order for our code to work, and as long as the user types in any other value than 0, this will work. So in order to ensure that the code is properly functioning with user input, the assert function can be used and utilized in order to find errors like that at real-time user interaction. So in order to use the assert function, you would have to include the preprocessor Cassert, and then you could actually test the code. Okay, so how do we use the assert function? You have the assert function name, and then you put in the expression. Okay, if the expression evaluates the true, the next statement executes. If expression evaluates the false, the program terminates and indicates where in the program the error occurred. So in order to use assert, you need to have Cassert included. Okay. So if you have a lot of assert statements in your code and you don't want those active, then what you can do is we can have this preprocessor directive, and we can type in define ndebug. So ndebug must be placed before the directive, the preprocessor Cassert, and then all the assert statements going to be disabled. So you would enable and disable asserts if you have some mistakes in the code, and when you ship it to the customer, then you would disable all the asserts, and you only use it as an engineer to debug, to troubleshoot your code. Okay, but that's pretty much what this chapter is about. And also based on this chapter, make sure that you look at the sample program in this chapter, the cable company billing program, because that's going to be your final project. So you're going to have instructions how to modify this code, but before you start working on the final project, Make sure you understand this code. Make sure you write the flow chart and the pseudocode for this code, and maybe you can ask some questions about it if something doesn't make sense. But this is a very good example of how you're supposed to design and think about code before you even start coding. How do you design? How do you analyze the problem and design the algorithm and then start coding? So this is going to be your final project, and we'll talk about it later on. But make sure that you spend some time, compile the code, run the code, play with this code, because you're going to be working with this. So don't skip over this exercise. Okay. So you can see that it will tell you how to name your variables. Why would you use some constants, and everything about the design of an application from a proper program design point of view. Okay, step by step. It will take some time to go through the whole code, but all your questions should be answered about how to write a more complex code. Okay, so see you guys next time.